Welcome to Homework Lib.
So over here we have the following diagram in which we are given three long straight wires which are going to have each a different current, and we want to know what is going to be the net force acting on wire A and on wire B according to the force per unit of length. So remember that the forces per unit of length in between two straight wires is going to be equal to the value for mu0 times the intensity of the first wire times the current of the first wire times the current of the second wire divided by 2 pi times the distance in between them. So the value for mu naught is going to be equal to 4 pi times 10 to the minus 7 in units of Tesla meter over ampere. So with this information, we're going to be able to get the net force on wire A and on wire B. So the first thing that we need to notice is that since both of these guys are going to be parallel to each other and they're going to have the same direction, the direction of the force acting on A due to wire C and the direction of the force due to B acting on A are going to be the ones that we're showing here. So since this is going to be our origin, notice that we're going to have a component on X and on Y for each of them. So first of all, the magnitude of the force due to C on the first wire is going to be equal to mu0 divided by 2 pi r. Let me use a small f just to notice that this is going to be directly Fc over L, just to have everything already on the same notation on this on this part, and this would be in current of A times the current of C. The magnitude of this force is going to be 4 pi times 10 to the minus 7 multiplied by the current of A, which is 1.6 amperes, times 3.3 amperes, divided by 2 pi times 0.25 meters. So we get 1.6 times 0.3, we get 4.224 times 10 to the minus 6 Newton per meter directly. So what we need to do is to find the component of Fc on the x direction and of Fc on the y direction. For this, we're going to use the following right triangle, which we know that this is going to be 60 degrees, and to know the component of the force, which is going to be the hypotenuse, the y component is going to, first of all, the x component, it is going to be positive as we see from our diagram, and it would be the magnitude of Fc times the cosine of 60 degrees. So for us, this would be 2.112 times 10 to the minus 6 newtons per meter on the x direction, on I. On the y direction, it would be the magnitude of the force due to C times the sine of 60 degrees, which is going to be 3.658 times 10 to the minus 6 Newton per meter on the y direction, so on the j unit vector. So now that we have the forces of C and due to now that we have the forces due to C, we can calculate the force due to B. So now the force due to B divided by the length is going to be equal to a small fb. This would be mu naught, or 2 pi r, current of A, current of B, which is going to be equal to 4 pi times 10 to the minus 7 times 1.6 amperes, in this case squared, since both of them are going to have the same value, over 2 pi times 0.25 meters. So 2.048 times 10 to the minus 6 Newton per meter. And now the force of B due to X and force of B on the Y direction. For X, we're going to do the same procedure. Now the triangle that we're going to be employing is the one over here. Oh, sorry, I forgot this needs to be negative, right? Because the diagram that we have here for the force due to C is going to go down. So in this case, both of the values are going to be negative, the one from X and the one for Y. This is going to be equal to the magnitude of FB. In the case of X, we're going to do the same thing. Cosine of 60 degrees. And on Y, sine of 60 degrees. So the magnitudes are going to be, since cosine of 60 degrees is equal to 1/2, this would be minus 1.024 times 10 to the minus 6 Newton per meter. And the force on Y, it's going to be equal to minus 1.774 times 10 to the minus 6 Newton per meter. So the overall value that we're going to get due to A on A is going to be equal to the force coming from C plus the force coming from B. On the x-axis, we're going to add up these quantities, 2.112 minus 1.024, which is going to give us 1.088 times 10 to the minus 6 on the I-axis, on the x direction. And on the y direction, we're going to have the sum of this quantity, minus 3.658, plus minus 1.774, which gives us minus 5.432 times 10 to the minus 6 on the j direction. And all of this would be in Newton per meter. And with this, we can calculate also, this is going to be the vector notation for f of a, and we can also calculate the magnitude of the force acting over here, and it's going to be the sum of the square for both of these quantities. Which would be a magnitude of 5.54 times 10 to the minus 6 Newton per meter. Okay? So now we're going to do the same thing, but now for wire B. Let's separate this stuff. And we're going to avoid some calculations since we already have done them. So first of all, notice that the force C that we're going to have here is going to have the same magnitude on this one. So in this case, the force due to C acting on B is going to be the magnitude alone, the value that we calculated here, but all of that is going to be on the x-axis and on the positive side. So 4.224 124 times 10 to the minus 6 on the x-axis. And the other one, the force due to A, is going to have the same magnitude as this one, but different direction. So the force acting on C due to A sorry, acting on, let me write down the same notation as the one that I did before. The force due to A acting on B is going to be equal to the x projection, but now this is going to be positive. It would be 1.024 times 10 to the minus 6, but with the positive is fine. And on the y direction, we're also going to have a positive value. And the trigonometric function is going to be the same. We're going to use same sine and cosine, and everything should work out. So in this case, it would be plus 1.774 times 10 to the minus 6. So all of this in Newton per meter, of course. So the net force acting on B using vector notation will be 4.224 plus 1.024, 5.248 times 10 to the minus 6 on the I direction, plus 1.774 times 10 to the minus 6 on the y direction with the j unit vector. And all of this in Newton per meter. And the magnitude of B would be 5.537 times 10 to the minus 6 Newton per meter. And with that, it would be all. Thank you very much and have a good one.